This is video 22, in which we help you get started with MicroPython LVGL 9 graphics on a Raspberry Pi Pico. The code for this video is at the GitHub site. This video on MicroPython LVGL is specific to Raspberry Pi Pico RP2040 board. All code examples have definitions at the beginning of the file to allow the user to alter as needed. As this channel covers multiple small system solutions over time, please subscribe to stay informed and click like, as that really helps. In this video, we set up an external Ili9341 display for an RP2040 Pico board with LVGL 9 graphics on MicroPython 1.20. We will show how to write the display and touch features. We will discuss our custom firmware build of MicroPython. Finally, we will review the code for a simple demo program. For this effort, I'm using the Pico MicroPython display baseboard, but any board supporting a Pico and its pins will work. I'm using the standard Pico RP2040 USB board with headers. Finally, we will use the Ili9341 display as the board includes integrated touch and SD card. The touch uses an XPT2046 chip. Make sure your display board contains the XPT2046 chip. Let's jump forward in time and watch the demo. We open the test Ili9341 demo program. On the Switch tab, we can turn a switch on or off, which changes the label text. Here the text is showing on, and the switch is on. I can click it and switch it off, or click it again and switch it on. On the Slider tab, we use a slider to adjust a value from 20 to 90. As we drag the slider, it changes the value of the arc indicator. Values below 40 on the arc display low and the line is yellow. It changes to green, and after dragging the slider above 70, it changes to red. On the checkbox tab, we can click to check or uncheck items. As we do, contents are updated in the text area widget. Now that we know that the display works, let's look at the steps to get there. We begin our research by reading the LVGL website and clicking links to their suggested MicroPython area. LVGL stands for Light and Versatile Graphics Library. The LVGL project, including all repositories, is licensed under the MIT license. The library supports a large number of microcontroller platforms and display hardware. The latest release is LVGL 9. While searching the internet, I found many examples using LVGL 8.3. And while looking for MicroPython, I found many examples for the ESP32 platform. Most of the LVGL 8 examples use MicroPython 1.19, and VGL 9 is built on MicroPython 1.20. For this effort, I rebuilt MicroPython for the RP2040 Pico, following the Get Started instructions. The resulting firmware provides MicroPython 1.20 and LVGL 9.1. A copy of my firmware is at my GitHub site. I found these two GitHub sites that provided the resources we will be using. The first link is the build source for the MicroPython LVGL 9 code. The second link is where I obtained the driver files that must be uploaded to the Pico. We look at the back of the Ili9341 display board and match the display pins to definitions in the driver file. We will also match the display's touch pins as well for XPT 2046 definitions. We can look at the Ili9341 test file to see the pin definitions. We need the hardware SPI 0 on 4 pins 16 through 19 and 2 control pins, which I used pins 0 and 1. But you can easily change these for your implementation. We look at the XPT 2046 test file to see pin definitions for touch. We use the same SPI 0 hardware-based pins and a different pin for the CS or chip select pin. Here is a picture showing the connections. Now, locate the Pico firmware file from Video 22 directory on my GitHub site. There's only 4 steps that you need to do to load the firmware. Click and hold the button on the Pico and plug the USB cable into a PC. A folder called RP2 will appear on the PC. Drag the file firmware.uf2 file to the folder and wait for it to load. The connection will reset. Reconnect the USB cable to the PC. To get the demo working on your desktop, go back to my GitHub site and download the other Video 22 files. The driver files are from the LV Binding MicroPython GitHub website. The Pico files are placed on the Pico's RP2040 device directory, as you can see on my screen. The desktop files are run from the Thony application. Rerunning a program requires a full power reset. In other words, you need to pull and reinsert the USB cable into the PC. Okay, let's look at the code. Open the file Ili9xxx test in Thony so we can verify the display wiring. Okay, I've opened the file to the Ili9xxx test program. You can see the pin definitions right here. To run the program, click the green run icon. This will run the test. Basically, it is testing the display using rectangle primitives in different rotations. However, if the screen remains white, then you missed a wire connection. Check each connection and look at the pin numbers defined in the file and change them if necessary. Now, let's open the touch controller file, which is XPT 2046-test. We can use it to verify the touch wiring. Usually, the touch controller is using the same SPI pins as the display. Click the green run icon, and the touch will initialize and run the test. Nothing happens on the display until you look at Thony. Using a stylus, I touched the display and the coordinates appeared. If you don't get any XY coordinates printed in Thony, then check your connection. Make sure the touch chip select is using a different pin from that of the display's chip select. Look at the pin numbers defined in the file and change them if necessary. Now, it's important that the touch driver be using the same rotation as the display. Right here in the file, you can see where the rotation for the touch is defined, and it's set at 1. If we go back to the demo program, we can see its display is also defined as rotation equals 1. These need to be the same, otherwise you'll have issues clicking on the right item in your display. Okay, let's look at the demo code. The top of the demo program has the driver definitions. These are specific to the class library being used. Also, these commands are specific to the Pico, as the ESP32 microcontroller needs different properties defined. Regardless of library, the display must be defined before the touch controller. So if we look through the code, you'll see I have all the commands to initialize the display and create the screen object, and then I initialize the touch screen. As I scroll down, you'll notice that the graphic command syntax is slightly different for LVGL9. And what I'm talking about specifically is this command to set the active screen. So for LGL8, it's lv.scr_act, whereas you see the longer version is used in version 9. Make sure when you look at examples in the internet that you're looking at examples that define the screen with lv.screen_active if you're using LVGL9. All right, let's continue to scroll down. And let's look at the UI. The first thing to notice is the parent-child relationship between objects on the screen. Graphical widgets are children of parent screen objects. Since I want the entire screen to be organized by tabs, I create the tab view as a child of the main SCR object right here. Then I create the tabs. When defining the first tab, notice I create the switch and a separate label as children of the FT tab. Okay, for this demo program, I created 3 examples in 3 different tabs. And although this isn't perfect code, the point of this was to share with you several different ways to implement LVGL graphics in MicroPython. So for the switch, you can see that I set the initial state to checked, and then I created the label. And here I have a function routine that just checks the state, and if the state is true, which means that I've turned the switch on, then it sets the text to on. Otherwise, it sets the text to off. Now, let's restart the program. Pull the power cable, plug it back in. Click the stop button to reset everything. Click the green run icon to start the program. Okay, you can see the switch starts off initialized as on. And now I can click it to turn it off, or click it again to turn it back on. Let's go down to the slider tab. And we'll check the slider tab. Here in the code, you see that I've created an event which I'll use in a minute. I've created a label for the text value, which is here. Next, I create the slider, which is at the bottom of the screen. And then I create an arc. I set its initial value to 20. And I also set the initial value of the slider to 20. And as you saw in the label, I set it to 20. Finally, I create the st_arc status label field, which is going to contain the state of the arc as I change the slider. I've set the arc's color initially at yellow because its value is low. Here I have a function routine to filter the values to make sure that they never go above 90 or below 20. And that was just an arbitrary feature. Here is the program to create the slider event. The way this works is the variable v gets the slider's value. It's filtered. I then set the value of the arc, put the value into the table, I put the value into the label's text, and then I check the value to see if it's high. If it's high, I want to change this arc to red. So let's try that. So if we move the slider all the way above 70, you'll see that the arc now turns red. As I move it back, the arc turns green, and if it goes below a certain value, it turns yellow. And all that code is handled here. To add an event to perform this function, you finally create a statement on the slider, and I use this function that we talked about earlier. And you see what the function does is whenever the value changes on the slider, it gets a new event, it grabs the value of the slider and stores that into the label. So the slider is using the event value changed feature on the slider to change the value and status of the arc. All right, that is the slider example. Let's move on to the checkbox. If we scroll down to the checkbox tab code, we see I set up the user interface by creating 3 checkboxes. For each checkbox, I set its position and I give it a label. Next, I create a text area field, which is this big white field here. I change its color. Normally, you can use the palette to change colors, and when you do, you can use palette with named colors. However, you can also set the colors using a standard color hex function, and here you provide the binary value in hex. And finally, I provide a color of the background for the text, which is, in this case, I want black. So as I do a check mark, it's going to populate this text area with black text. All right, how do I update that? Well, I have these functions right here. So of course, we have an event callback, and I put an event callback on each checkbox. So the event callback gets the state for that checkbox. If it's checked, then the state will have a value of 3. It then gets the text. In this case, I have selected cherry checkbox, so it's going to get the text cherry, and it's going to store that value in this check1 variable that I created. And then it's going to call this update the text area, which runs this routine here, which just displays my list based on whether or not something has been added. So if I add banana, you'll see it is added to the list. If I add apple, it's added to the list. If I click on cherry to uncheck it, it's removed from the list. The same with apple or banana. All right, I put a routine for each checkbox, and then at the bottom of the code, you'll see I added an event on each checkbox. And the way this works is it looks to see if the value's changed, and that triggers an event, and which calls this callback routine. At the bottom of the file, we have a statement that will load the screen. And then finally, I added this theme, which you don't have to, but by default, the screen will be white. What the screen does is it set this default values on the screen of blue and red, and it gives me a nice black transparent background. Finally, the most important thing is at the end of your of the file, you must have an event loop program. You must have this infinite loop program. Now, when you initialize the display, the software will begin an event loop. So you don't have to create an event loop, but you do have to have this loop at the bottom of the program. Otherwise, the code will exit out and stop. And the only thing you need is this timer handler and this time delay. And just to show that you can do it, I added this check switch function that shows that you can add your custom code inside that event loop to do things. Well, that's it. In summary, we researched the LVGL and located resources. We wired the Ili9341 TFT display and the XPT 2046 touch controller. We verified the hardware drivers. Finally, we reviewed the demo code. Thank you for listening.